All right, welcome. Good morning, everybody. So, game plan today is to continue the idea of systems of equations. In the last class, we had three systems of equations with three variables, and now today we're just going to see what happens when we graph these equations. So, this is just for us to get a general idea and flow for the class. So, let's say it says sketch the lines given by x plus y equals 6. So x plus y equals 6. Okay, remember, this is a line. And here we have the other line, negative 3x plus y equals 2. And now what the question is saying, it says sketch the line. So if this is our coordinate axis, right? This is our x-axis over here. This is our y-axis over here. How can we graph these two equations? Well, let's see. Remember, whenever you're graphing, you always want it in the form y is equal to mx plus b, right? This is standard form for a line, okay? Now here, if we have x plus y equals 6, how do we get it into this format? Well, basically, you just want y by itself. So here, how do we get y by itself? You just do minus x. Now here, y is equal to negative x plus 6, okay? And I could say that y is equal to 6 minus x. That's also true. But remember, you want it in mx plus b format. You want this x to be on the left side, okay? So even though these two are equivalent, having it in this format is what we want, okay? And then what about this one? How do we get this one with y by itself? This is plus 3x. And now here, y is equal to 3x plus 2. And remember, the question is saying graph these two. So there is a way to graph it without the calculator. But here, let's actually just use the calculator. So remember, let's go to second quit. Let's actually reset the calculator real quick. So remember, it's second. Wait, let me zoom out a little bit. This is zoom in. Okay, so second memory. Go down to reset. All RAM, reset. Okay, so now it's reset. Now let's plug them in. So the first one we're going to plug in is negative x plus 6. Okay, so this is this line. And here, y is equal to 3x plus 2. We're going to go to our y2 function. This is our y1, and this will be our y2. And this will be what? 3x plus 2. And instead of just hitting graph right away, which you can do, well, all right, it's already in standard form. So here, you could also go zoom, standard, and yeah, okay, you get the same thing. So this is the general idea of the graph. And notice that this equation and this equation, remember, when you're solving these systems of equations, you're finding a point that they both share. So what is that point that they both share? Well, that's you solving for this. Here, if I say y is equal to negative x plus 6 and y is equal to 3x plus 2, how do we find that point that they share? Well, here, what we could do is we could just say if y is equal to this and y is equal to that, let's just make them together. So negative x plus 6 has to equal 3x plus 2. And now let's solve for x. So here, we could do plus x, and now 6 is equal to 4x plus 2, minus 2, so 4 is equal to 4x. So this means x is equal to 1. So we know that at this point over here, the x value of this coordinate point, remember a coordinate point, remember it's some xy. Right? It's some xy, it's some point. So we know that the x value for this intersection is going to be at 1. And if we know it's at 1, what's the y value over here? Without doing anything in the calculator, just algebraically, we just plug in 1 into either one of these equations. And if I put in 1 into this one, it'll be what? Y is equal to negative 1 plus 6. So y is equal to 5. Or if I put it into this one, it's the same thing. Y is equal to 3 times 1 plus 2, and y is equal to 5. Right? So we know when we graph these two equations, if we look at this one, what I'd like you to do is take your, you can just mark it. So this is 1, this is 5, right? 1, 2, 3, 4, 5. So they share this point. So the graph will look something like, okay, so we just have a line like this, right? And now we also have a line kind of like this, okay. And they share that point. They share that 1, 5, okay? And that's what the question is saying. It's saying, sketch the line. Here, let's go back. It says, sketch the line given by x plus y equals 6 and negative 3x plus y equals 2. So we graph these two equations. But let's see, which is which, though? This equation is which one? How do we know which one it is? Well, we could just go out of here. Let's go back to the y. Let's clear this one. Let's see what 3x plus 2 looks like. And if we just do graph, okay, so this one is 3x plus 2, right? Oh, there's a glare. Okay, wait, is this better? Ah, yeah, that's better. Okay. So this is 3x plus 2, and the other one is y is equal to negative x plus 6, okay? And they share that 1, 5, and if you want to see a cool little trick to actually see, here, let's actually put that in again. So this is negative x plus 6, okay? So graph. If you actually want to see where they intersect and how to do that on the graph, it's a nice little trick. Let me show you with the calculator right now. What you do is you go to, so you want to hit that calc button. So you go, it's on trace. So you go second, which activates the yellows. So second trace, and then go to intersect, okay? And then from here, you basically choose a point that is on this line and that's close to this line. So let's say it's over here. We just hit enter, right? And now it says, let's look at the other line. Oh, and it even tells us right here. It says that y2, that 3x plus 2, which is this line, we just kind of estimate the second curve. You just estimate. You hit enter again, and then you hit enter again. And you see, look here, it's going to say guess. So it's going to guess the point of intersection, and if you hit enter, it says intersections at x equals 1 and y equals 5, which is our we algebraically did it here, and by the calculator you can also show it here, okay? So the next question is telling you to do is, suppose the second line is replaced by the line with the equation x plus y equals 2. So here it says sketch the lines given by x plus y equals 6, x plus y equals 6. But remember, this is equal to y is equal to negative x plus 6. So this is line 1. Line 2 looks like what? It looks like x plus y equals 2. Okay? So what they're saying to do is plot two lines on the same set of axes and solve the pair. So what are we going to do is, let's draw these out and then we're going to solve it. Okay? So here, this y is equal to negative x plus 6. We already have that, right? So this one we keep. But how do we have to get this x plus y equals 2. We have to get it in what format? We have to get it into the y is equal to mx plus b. So here, if x plus y is equal to 2, y is equal to negative x plus 2. Okay? And let's see what this looks like. It's negative x plus 2. And if we graph it, notice we have two lines, and they look like this. And what's different about them, they don't intersect each other like they do here. So what if you were given a system of equations and they said, okay, find a plus 2. Hey. Oh no, it's okay. Okay, so going back to this. If we were to say, let's solve this system of equations, right? Y is equal to negative x plus 2 and y is equal to negative x plus 6. here, when we draw these two lines, right, they have no point of intersection. You see here, there is an x and a y that if you plug it into both equations, you get something true. But here, it won't happen. Because let's say if y is equal to negative x plus 2, and y is equal to negative x plus 6, we can set them equal to each other. And this, if we try and solve for x here, watch how weird it gets. It gets very weird. So this is minus 6, and you get negative x minus 4 is equal to negative x. And if we add x on both sides, right? Let's say if we do plus x, oh, whoops, sorry. Here, yeah. So let's say if you have negative x plus 2 is equal to negative x plus 6, and now it says solve for x, right? Okay, so let's do minus 6 on both sides. Here, I'll just write it again. So minus x plus 2 is equal to negative x plus 6, right? So minus 6, negative x minus 4 is equal to negative x. And then what do we do? Let's plus x. What do we get? We get negative 4 is equal to 0. This is very weird. And what this basically means is that there is no xy value that when you substitute it, there is no point that this line and this line share. But in this case, in this example here, there is a point, this 1, 5. Because if you put 1, 5 into this equation and into this equation, then they both will be true. Because look, x plus y equals 6, right? So if I put in 1, 5, remember, x is equal to 1, y is equal to 5, you get what? You get 1 plus 5 equals 6, 6 equals 6, and this is true. But what if I do it for this one? If I say negative 3x plus y equals 2, let's put in 1 and 5. What do you get? You get negative 3 times 1 plus 5 equals 2. You get negative 3 plus 5 equals 2. And negative 3 plus 5 is equal to 2. So 2 is equal to 2. This is true. This is true. So you see, when you put in that 1, 5 into this equation and this equation, you get a true statement. They're true because they share this point. But here, there is no x or y, there is no x and y value that if I substitute it into this equation and this equation, you get something that's true. Okay? So this is what happens when you're solving systems of equations. Remember, if you have two lines, right? Think about it. You have two lines. How many ways can these lines interact? Well, we just saw that two lines can intersect at one point, right? They could intersect here. They can never intersect, like this example here. And is there another way where two lines can interact? And I want you to think about it. Like, let's say if you have two lines, two straight lines. Can two straight lines intersect at 2 points? Is that possible? Can I make like another line and it, no, then that's not a straight line. So, but what's another way? So two lines can hit 1 point, they could hit no points, and if you do the next question over here, let's see what happens. It says, suppose the second line is replaced with the equation 2x is equal to 12 minus 2y. So remember, the first equation is what? X plus y equals 6, right? So if we have x plus y equals 6, and that's equal to what? Y is equal to negative x plus 6. So this is our line 1. Here, what's our line 2? Our line 2 is 2x is equal to 12 minus 2y. And now here, if I solve for y, if I want y by itself, what do? Let's just get everything to the other side. So this is minus 12 minus 12. So 2x minus 12 is equal to negative 2y. If I divide by negative 2, I divide by negative 2. Y is equal to negative x plus 6. or y is equal to negative x plus 6. But wait a minute. This line and this line, they're the same line. These are the same line. So you're going to have two lines. This is line 1, and then maybe this is line 2. They overlap each other. They overlap. So they're both the same line. Every xy value will satisfy both equations. Okay? So if you have two lines, three things could happen. Either they hit one point together, they hit no points together, or they hit all points together. They're the same line. Okay? So that is what this is saying. It's saying we have seen that the pair of lines can intersect at one point. It could hit at 0 points, or it could hit at an infinite number of points, such as this. And are there any other possibilities? Nope. There are not. Okay? So that will do the first section here. This is just a general idea of what's going on. Okie dokie.